We have natural killer cells, and they disintegrate and dissolve and kill cancer cells. That's one of their key jobs. As, believe it or not, every one of us has had cancer. Now, when you have when cells replicate, and there are millions and millions of replications all the time going on, when that happens, occasionally something gets coded wrong in the DNA. And if the right things get coded incorrectly, what you have is a cell that can start growing as a cancer. But these natural killer cells, they wander around the body looking again at anything that's just unusual. And if they come up with something that is strange, they destroy it. So they destroy cancer cells. They also work on virus infected cells, because cells that have viruses in them actually put on the surface of the cell some components that the viruses code for, and that makes the cell look different. Now, the inflammatory response is triggered when body tissues are injured, and there are 4 common indicators of acute inflammation: redness, heat, swelling, and pain. There is also a 5th one if the inflammation is bad enough, called loss of function, but we don't consider that the primary example. This process results in a chain of events leading to protection and healing. So here's a general flowchart for inflammation. Something damages the tissue, and the cells in the area get damaged. Now, there are things inside of cells that should not be outside of cells. So when you end up damaging a cell, it leaks out this material, which causes these materials, which are kinins, histamine, and other chemicals, and that causes several things to occur. Locally, blood vessels dilate, and that allows immune system cells to come in. So the capillaries become leaky, and you end up getting fluid into the area, which causes edema and swelling. And then through the chemicals that have been released, we get neutrophils and monocytes and other white blood cells, which are drawn into the area. Now, the increased blood flow into the area leads to the redness and the heat, because blood is hotter than body temperature. The edema results in pain, because we've got these fluids now that are causing the tissues to be tight, and as a result compressing some nerve endings. And then we have swelling as a result. We have clotting proteins that will enter the area that will stop the immediate bleeding, and then we can start doing some repair. Neutrophils and monocytes are involved in removing of damaged and dead cells and tissues and any pathogens that got into the area. Now, because of the redness and the heat, we get more nutrients and oxygen into the area, which increases the metabolic rate of the tissues, which allows faster healing. Due to the pain and the swelling, we limit movement, so that allows better healing to occur. And then we have the clotting proteins, which will make fibrin, which will ultimately be broken down after repair has been completed, and we end up with healing. So, functions of the inflammatory response. Basically prevents spreading of the damaged agents, disposes of cell debris and pathogens through phagocytosis, and sets up a stage for repair to occur. And here's just a graphic to show kind of what can happen. You get a nail attack, a splinter, something like that that goes in, damages the tissue. And that causes that release of chemicals, which causes inflammation to occur in the area, and also causes blood cells that are normally in the vessels to come out of the vessels and get into the area where the damage has occurred to do cleanup. Second line of defense cells include antimicrobial proteins, which will attack microorganisms and hinder production of microorganisms. There are a couple of important ones. One is the complement proteins, and the other is something called interferon. Now, the complement are a group of about 20 proteins that are floating in the blood plasma. And they get activated, again, by release of those chemicals, which causes a complement fixation. So we've got damaged tissue, we get chemicals that occur which cause complement fixation, and these proteins basically form a tube, almost like a needle that pokes holes in the foreign invader. So it damages foreign cells, it releases vasodilators and causes chemotaxis, and that is where the cells migrate to where there's tissue damage. It removes chemicals and causes something called opsonization. And if you think opsonization, think optimization. It makes the foreign body more, appetizing to the cells, the neutrophils, and the macrophages. It's kind of like putting mustard and ketchup on a hot dog. So you can think of complement being a condiment and opsonization being optimization as a result of that. It just makes the foreign body more appealing to the immune system cells. So here's an example of what happens. We've got an antibody that will attach to a pathogen membrane, and that will cause this membrane attack complex to form. So we've got complement activated. This is for opsonization to occur. We have to have been exposed previously to the microorganism. We have to be making antibodies against it. But the complement system itself reacts the same way to every microorganism. So although it's activated by our specific immune system, it is a general immune system response. Now, interferon is produced by virus-infected cells, and it is a messenger that is sent out by the infected cells to notify adjacent cells that there has been an attack. Those adjacent cells can take action which will prevent them from getting invaded by the virus. So it binds to healthy surfaces to interfere with the ability of the virus to enter and multiply. It's kind of like you've got an infected cell and it screams out to shut the windows and lock the doors because there's a killer on the loose. And so all of the other cells go into a self-protective mode. Fever, that is an abnormally high body temperature. And this is a whole body response. But what happens is when you get tissue damage and you get the sufficient type of damage, then the body cells produce something called pyrogens. And these pyrogens get picked up by the hypothalamus, and it resets your body temperature. Remember, we said that the hypothalamus regulates all sorts of body functions. Well, one of them is body temperature, and it says, okay, we've got invaders in here. We're going to up the temperature a little bit, because that high temperature is going to inhibit a couple of things. It will inhibit the release of iron and zinc from the liver and spleen, which are needed by the bacteria for them to multiply. And fever also increases the speed of tissue repair by increasing the metabolic rate. So that was a quick and dirty overview of the innate immune system. And again, it consists of skin and other structures, as well as phagocytes, natural killer cells, the inflammatory response, antimicrobial chemicals such as complement, interferons, and oddly enough, urine, which has a acidic pH and will inhibit the growth as well. So it cleanses the urinary tract as we pee. And then fever, as we mentioned before. So a few things to be aware of here. You should know the inflammatory response and the various steps involved in the inflammatory response. You should understand what are the cardinal signs of inflammation. You should know that complement, interferons, and urine are part of antimicrobial chemicals, that interferons specifically are associated with virally infected cells. You should know the general purpose of a fever. So hopefully that helps everyone, and that's it for me. We'll go on to our specific immunity in a later presentation.